Hello there, I am Mohammed Bello Garba, Community Medicine Department, ABU Zaria. We are gradually moving to the crux of biostatistics, that is inferential statistics. In the initial module, we discussed the general introduction to the science of biostatistics. In the second module, we talk about descriptive statistics, measures of location and dispersion. In this module, we'll discuss about inferential statistics, which we said is the science of drawing conclusion from data collected using samples to the parent population. And we say it is the crux of biostatistics. We also need to mention that in inferential statistics, it's just made up of two major branches also. The first one is interval estimates and hypothesis testing. And we'll start with the interval estimate. And it is called confidence interval. And what is confidence interval? Confidence interval is a range of values characterized by upper and lower confidence limits that describe with a degree of assurance or certitude that the population mean will fall within these intervals, even with repeated sample from the same population. So it saves us the time of getting repeated samples, and it is based on the statistical principle called central limit theorem that shows that if the population is large and the parameter is normally distributed, and you take a repeated sample from those population and you calculate the mean, and you plot this mean in a form of frequency polygon, then it will give you this normal distribution. And part of the characteristic of normal distribution is that it can be determined by mean and standard deviation. So if you have a mean of a sample, you don't need to go repeatedly collecting data from the same samples, because it will give you some certain level of precision of getting the population mean within those intervals. And that is the general formula for confidence interval. And it is given as confidence interval is equals to estimate plus or minus confidence coefficient times standard error. This is the general thing for ease of remembrance. And this estimate could either be mean or proportion, depending on the nature of the variables. And if you take minus, it will give you the lower limit of the confidence interval, and then take the plus of it to give you the upper limit of confidence interval. For normally distributed data, our confidence coefficient is z alpha minus 2 proportionate to your degree of confidence interval. And the standard error is standard deviation all over root of n. That is for mean. For proportion, we can also do the same for proportion. And the confidence coefficient is the same, but the standard error is proportion, and the complementary probability for the proportion. It will give you standard error for proportion. And usually Q is given by Q is equals to 1 minus P, because the principle of probability shows the total probability space equals to unity, that is 1. And if you know the proportion, then 1 minus the proportion will give you the complementary probability. We also know that you can describe 3 levels of confidence interval. We can have 90%, we can have 95%, which is the usual, though the commonest one used, and we can also have 99% confidence interval. So to demonstrate how to calculate confidence interval and its interpretation, we give 2 examples to do that. If we take, for instance, a population of infants in a community, 100 of them, you take 100 infants and you take their weights. So n, our n here, where is it? Our n is equals to 100. And the mean weight is equals to 10 kg. And you take your standard deviation to be 2.5 kg. And you are asked to calculate 95% confidence interval of this population. So let's see. Because it is confidence interval of mean, so we will use this formula. Okay, because the variable weight is a continuous variable and fairly normally distributed, and we are using mean, so we use confidence interval of mean using this formula. And because 95 confidence interval is the most commonest use, so we use 95 confidence interval. So our mean is 10. And I told you, when you are calculating confidence interval, you start with the minus, because this is plus or minus. And confidence coefficient for the Z distribution for 95 confidence interval is 1.96 times our standard deviation is 2.5 all over root of 100. This will give us 10 minus 0.49, which will give us 9.51. This is for the minus. If we take it to 10 plus, for the plus side, because this is we're using the minus sign, this one will give us the lower limit. Lower limit. And then if we take the plus, it will be 10 plus 0.49, which will give us 10.49. Therefore, you can say 95% confidence interval will range between 9.51 to 10.49. And the interpretation is this. With the repeated sample from these 100 infants in the community, repeated samples of infants in this community, we will yield a mean weight ranging between 9.5 to 10.49 with 95% degree of confidence. Now, let us demonstrate an example of confidence interval of proportion using our parent formula. We said that the parent formula for confidence interval is the estimate. Here is a proportion, plus or minus confidence coefficient, which is our z-score of the two-tail, times standard error. And for proportion, standard error is PQ, root of PQ all over n. So let us take proportion of children that are anemic in a community. Let's say the proportion is 33%. P is 33%. So our Q will be equals to 1 minus 0.33, which is equals to 0.67. And if our n remains 100, for instance, so let's see. If we want to calculate 95% confidence interval of proportion of children that are anemic in that community, what will it be? So we'll start with the minus, because it is plus or minus, as I have said. So it will be 0.33 minus 1.96 times 0.33 times 0.67 root of all over 100. This one will give us 0.33 minus 0.102. And this will give us 0.228 for the minus. But if we take, and this will be the lower limit,